Welcome everyone to the Isaac Computer Science GCSE Livestream.
Are we all ready for another instalment of Computer Science Chaos?
I'm kind of hoping for more Computer Science calm, Katie.
You know what? Computer Science calm does sound good. Do you think we could pull together a Computer Science mindfulness series?
Ooh, feeling compressed by compression, malicious software giving you nightmares, strung out by strings?
Computer Science for the soul.
I think you could be onto a winner there, Katie.
Speaking of winners, this seems like a perfect time to segue into introducing our guest host. This week, computer science teacher and former software engineer Melanie Denig is back for more programming concepts.
Yes, we are so glad to have Melanie joining us again this week to take us through arithmetic operators. As always, if you have any questions during the live stream, please either share those in the chat or by using the question form below.
So without further ado, let's welcome Melanie back to the live stream.
Hello from me.
Hi, Melanie. Thanks for joining us again. How are you today?
Very well, thank you. It's getting a bit dark, and with any luck, the lights will stay on. Forgive me if it suddenly goes a little bit darker in here. It's because we're on autopilot with the lights, but I will stay.
Brilliant. It's great to have you back with us. This is your second session on programming concepts. For those who weren't with us last week, Melanie, could you give us a quick recap on sequence selection and iteration?
Yes, because we will be seeing those concepts today, of course, but with added complexity to it. So we were talking about those basic building blocks. What I mean by that is, what does a programmer really do to get the computer to do stuff? So clearly we give instructions, right? We give instructions. So we can either give an instruction, give another instruction, give another instruction. We call that a sequence of instructions, which would make for very, very boring programs, because we wouldn't be able to interact with them, because at a certain point what we would want is that sequence of instructions to be interrupted by a condition. So for example, if you click on a button, that would be a condition within the computer. So it would say, if button click, then do something else, and that might lead to another sequence. So we've got a sequence, but we've also got a condition, a selection where things go different ways, could go one way or another. So straight away we can build much more interesting programs, because we did that with our little chatbot. So depending on the answer that we're given from the user, we go one way or another. And then of course we have this idea of a repetition, of a loop or an iteration, because computers are really good in doing lots and lots of stuff, and lots of that stuff is repeated instructions. So we can identify a block of instructions that we're going to repeat, but ideally not forever. So we're repeating a block of instructions, and we're saying, well, repeat this block until a certain condition is true, and then you stop. And we also look at the idea of turning this around. So we say, whilst a certain condition is true, do this stuff. That would be your precondition loop. And then we've got the counting loop, where we count a number of times and we repeat something for a number of times. And I will actually sneak one in at the end of the session. And today we'll be seeing, well, computers are very good with numbers. How do they do that with arithmetic operators?
That sounds brilliant. And we had lots of love for the live code that you did last time. Have we got any of that today, Melanie?
We do. So there is a link to an online coding platform different to what I used before. So before we used Python. I will get around to showing some Python. So if the people who are watching us today, if they get idle open or any other Python environment, so you can try things out that I'm demonstrating, and I can maybe show you. But for our main code block that I'm showing today, it's on an environment called P5, which I'm a big open source fan of. And it's built on top of Well, I wonder if people can guess the language. Why don't we do that? I'm going to say which programming language it is, but they can either you ask me or maybe some people in the chat.
Excellent. So don't forget to add that in the comment if you think you know what it is. And Melanie, take it away.
Excellent. Thank you very much. So here we go. So arithmetic operators. What you see there as our first few bubbles, these are the operators that I will be talking about today. So we'll have our common operators, and I assume most of them you know already. You've been working with this stuff ever since primary school. So just because it says arithmetic, please don't, get yourself pinged back into the math lesson you may have had today in secondary school. No, this is computer science, but computer science does need some calculations because computers are really good at that. And added to those common operators that you already know, I will talk about what we mean by integer division and how we do power of. So that's taking a number and taking it to the power of another number. I will talk about modulo, which I don't think the majority of people will have done. It's one of those things where computer science races ahead of mathematics. And finally, I'll be talking about the order of precedence when we execute these operators in sequence. Again, it may not be exactly the same as the way you know it from mathematics. So first of all, I want to remind you of what we mean by numbers. Well, you know this again from primary school, and that's why I used this number line just to put everybody in a comfort zone. Numbers, this is what we mean. But what do we do with numbers? Well, we combine them, and what an operator does is it takes two numbers and operates with those two numbers, and it gives us a new number. So just as a simple example, just so that we're really clear what we're talking about. So I can take the minus 40, and then I take the operator minus, and then I put it together with minus 10, and I get a result. Those of you, who are quick with that sort of stuff, you of course know the result, but it should give us a minus 30. So that keeps us on that number line. And then we can take that minus 30. So we've got a result, and now we combine it with another operator, with another number. So we have got the minus 30 divide by minus 2. And again, those of you listening and watching us, you will already know, well, that's a negative 15. Now, what we do when we have the minus 15, then we can now say, I want to divide that, but careful now, because there's a different symbol which you may not know. I use the double slash, and that is the Python symbol for an integer division. It may not be the same for a different programming language. So what I mean by that is, it's, again, remember back in primary school, what would you have done? You did a division, but then you worked with this idea where, well, how often does that go in there? So minus 15, integer division by 2. I want a whole number. I only want a whole number. So that whole number now is the negative 7. So an integer division gives you a whole number. That's the big idea. It gives you the whole number. It's something that mathematicians call floor, but we don't need to know that term. All we need to know is I want the whole number. So it's not rounding up, it's just getting rid of that decimal part of that number. So I've got my minus 7. What can I do with the minus 7? Well, what about with the minus 7 if I now take it to the power, and that's the double asterisk. And what's important there, I take it to the power of a 2, and you notice, well, whoa, that's not going to fit, because if I take something to the power of something else, I tend to get a much, 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 much larger number. I should qualify. We want this 2, but we take it to the power 2. Yeah, so if I'd say minus 2 to the power of 2, if it was a negative 2, it would be a different story. But for now, we only talk about positive numbers as the exponent. So these are sort of the common things. The integer division may be a bit new, but fundamentally, the integer division is something that maybe if you have a much, much younger sibling in primary school, they can do that and you can still do that. So it's just taking the whole part. And again, just making the point, if I take something to the power of another number, I get something much, much larger. Not so important maybe for GCSE, but at A level, you really need to be aware of that scale, what happens when when we have something that is exponential. Right. In summary, so this is what we've done. In sequence, we took two numbers, combined them, we got a result, we took that result and used another operator and so on. So we went ahead like that, which is fine. And a lot of your calculators will work like that. What I mean by that is you punch in minus 40, you punch in the minus, and then you punch in the minus 10. If you don't hit the equal sign, if you just hit the divide button there, you may already get the result. So it's something that you need to be aware of. What happens if your final result is just doing things in sequence? So you need to be aware of, what does my calculator actually do? Does it just operate everything in sequence like I've done here, or does it do something else? Does it actually observe what we call precedence? So I just want to go back because it's a bit tricky. So here I've done something in sequence. I got a result and then straight away I operated with something else in sequence. But actually these things, they don't always work like that. So if I do it in sequence, I get that. But my operators have a precedence, right? What do I mean? I mean, if I don't execute, if I don't calculate just in sequence, left to right, I need to do the power of first. So if I have my long line, I need to do the power of first, and then the next row, they're all the same. I explain how that works. And then the bottom row here, the plus and the minus, they have the lowest precedence. So that I do last. Okay. What does that mean? Well, that means if I have a sequence like I've written it now, the minus 40, the minus 10, etc. If I've got it written in a line, I can't just do it like I did as you see it on the left. I can't. I'm not allowed to do that. I need to observe what we call precedence. And those of you who like to think ahead, you may already now have the result. And voila, the result is actually my 48, right? So if I have time, and I will just grab that time, I will quickly present I will try and show you in Python how we can test that. So if I go and share my screen, and I share the screen, and then I share screen 1, and then here I get idle up. So in here, you can just test this out. Then you can, not sure if you can, here we are. Hopefully you can see my screen still. Yes, you can see idle. So here I can just test that out. I can say, what about if I have 5 plus 2, and then I say multiply by 2. I get a 9, right? But if I do 5 plus 2, in sequence, I get a 5 plus 2. That would give me a 7. And then the 7 times 2. Well, that would be a different result. So it's super, super, super important. It's super important that I get that right. And you can absolutely try that out on idle right now. I'm just going to hide this screen again. So we've got this idea of the precedence, and I'd like to get back onto full screen, but I may just leave it like that. So modulo is our next tricky concept, and that is the one where I said it's most likely be new to you. So modulo, what do we mean? It's a weird word, right? Well, it's simpler than you might think at first. Modulo, what does it mean? In Python, the operator is this symbol here, the percentage symbol. I don't know why it's the percentage symbol. I don't know why they've chosen that, but in Python, this is the operator. So if I have a number and I combine that with the modulo operator, people want me to go full screen. Is that better for people who can see me? I genuinely don't know how I can go back onto full screen. It was so nice. Let me just try something else, slideshow. If I go like this, is this better, people in the chat? Brilliant, thank you, Laura. Right, sorry, going to the right place. Precedence we spoke about, modulo. I started talking about modulo. So we've got a number and we take the moderator modulo and we put another number next to it. So some number modulo 4. What that means is whatever number I've got, if I did divide it by 4, what is the remainder, right? So that means that remainder, and this is quite a tricky concept, that remainder, that result that I'm getting can only ever be 0, right? Because if I take a number and I divide it by 4, I may get a result of 0. And those of you who like to think ahead, what does that mean? Well, that means that number is divisible by 4. Because if I divide 8 by 4, the remainder is 0. But what if I take 12 and I divide 12 by 4? The remainder is also 0. So it's amazing stuff. And if I now go to 9 and divide that by 4, the remainder is a 1. But if I take the 13 and divide that by 4, the remainder is a 1. So whatever I put there, whatever number I'm getting there, it always stays within that range, and it's super, super powerful. At A level, you learn about encryption, and it's very, very powerful in encryption. Right, so modulo, again, another example. So now, those of you who like to think ahead, you think now, but what is the range of my result? What numbers can I get if I take a number modulo 5? Well, ta-ta, this time it's 0, 1, 2, 3, and 5. So modulo, super powerful and really, really useful for a lot of stuff. And I will show you some examples in a moment, because the range we've got now, we've got our common operations, the ones that you know ever since primary school. You've learned maybe something new, which is the integer division. Well, actually, it's not new. It's just what computer scientists call that kind of division that you've done in primary school. Then we've got the idea of power of. Well, that's taking a number and then another number, and the one number is taken to the power of another number. And the big idea is there, you get a much, much larger result. Modulo, a new word. Maybe it's a new word, but actually it's again that thing that you did in primary school when you said, oh, what is 9 divided by 4? I'm sure you would have said it's to remainder 1. Right, brilliant. So that means I can give you the summary of the precedence, but oh, what I didn't say, by the way, there's maybe a question now, what do we do with that in the middle? So all of these in the middle, the multiplication, the divider, the integer division, the modulo, what I did not mention is what's the order of precedence there? Well, it depends. You really, really have to check the programming language. So in most programming languages, if you put them in sequence, it's left to right. But it may not be the same, so you have to check the programming language. Does that mean that I can say thank you and show you the examples? What a nice little trick working with modulo. Just waiting for a response in the chat. I think I can go on to that. Brilliant. So I'm going to have to go to a different screen to show you my code example. And I'm just going to do it like this. In the chat, I know the text is very difficult to read, so what I'll try and do, in a moment I will zoom in, but first I'm just going to demonstrate. So here's my code, and when I run this code, you can just about see up here, I've got some circles. I'm drawing some circles. So when I run the code, they will start coming to drop down. So let's drop them. I'm going to run. There you go. They come down, right? And the way I've coded this, that each of my circles, and because I mentioned simulating rain last time we were here, I called it raindrops. So it's the idea that I'm going to stop this again, I'm going to do it again. How could I use this to simulate rain? Well, because I don't want them all to come down at the same rate. So my drops, I don't want them all to come down at the same rate. That wouldn't look very realistic. So the question for me was, this is a while ago, but if I want to simulate rain, what could I do? Well, first of all, I'm just going to highlight this bit of code and zoom in. What I can do, first of all, I'm going to have a list, or an array in this case, of raindrops. So you can see I called that cloud. I said I'm going to have a cloud, and in my cloud I'm going to stick lots of raindrops. Don't worry about the syntax of this language, just the idea of I've got a cloud, and then I'm going to put the for loop, I'm going to put raindrops in my cloud. And don't worry about all this curly brackets, it doesn't matter. What matters is that here I've got a for loop then, and I'm going to draw my raindrops. I'm going to go through my list and I'm going to draw them, right? I'm going to draw my drops. So what happens is that, imagine this. So can you see my board? Yes. So I've got a list or an array, and I've got in each element, I've got a drop, a dot, a circle. But because it's a list, I've also got some numbers associated with these, which each element, I've got a number at the bottom. And what I mean by that number is, this is my I. Look at my code. When I say I from 1 to maximum drops, because these are my indices. So I used I. And what I'm doing as I'm going through, as I'm going to let something drop, right? They're all going to come down. They're all going to come down. But I am checking, my I. So I'm checking this number. So if this number is divisible by 2, so if it's an even number, then you are dropping down at a rate of 3. If this number that I'm checking is divisible by 3, which is what's happening here, then that was silly. Same rate, I want a different rate. And I want this to be also at a rate. I'm not sure why this appeared. And if it's divisible by 5, I'm going to let it drop at a rate of 1. So depending on, if you like, the divisibility, I'm creating a different pattern. And I'm just going to run that code once more. And there we go. They're all dropping at a different rate. They're all dropping at a different rate because I'm checking, right? I want you to drop, but I'm only going to let you drop at a rate depending on what number divides you, right? And that is my creative use of Modulo. There are many other uses of Modulo, but maybe we could do that. Oh yeah, if we ever do a live session on lists, that would be another good moment to talk about Modulo. But in the meantime, I'm waiting for questions.
Thank you so much, Melanie. That was great. And I absolutely love the rain simulator.
Thank you.
Yes, and I think that description of modulo as from like when you did long division at school, that's actually a really nice way to describe.
Yeah.
So we've had one guess on your challenge that you set people. Is it based on C++?
That is a very common question. So the answer is no. Most languages, I will say, are based on C. That means even Python is based on C. So often what we see, the first line of code ever for the compiler for a language or interpreter is written in C, but then everything else unravels from that. But it's not based on C++. Any other guesses?
That's the only one we've got so far. Laura, do you want to have a go?
Oh, pressure. Let's go. Oh, JavaScript.
Oh, very good. Yes. And so it is JavaScript. Now, it's really funny whenever I use this in school, this language, P5 or JavaScript, students tend to go, oh, it's so bad. JavaScript is really bad. And yes, it's bad for many, 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 many things, JavaScript, because the error correction is really bad. However, you know what? It's the language of the web. So if I do something in a browser like I've done today, do it in JavaScript. So, I'm a great believer in do what fits the tasks. So, and I really, really like doing visual stuff. So P5 allows me to do that. And as I said before, it's a great open source project. So it's dedicated to education. It's great.
Great, thank you, Melanie. Are you ready for some questions from our audience? And as a reminder, or you watching at home still have time to ask Melanie questions using the chat or the form that has just been listed again below. So, Katie, have you got our first question?
We have got another question for you. How important is this topic, especially modulo? Will people see it in their exams?
So it can be hidden. So I remember, funny enough, the first cohort that I saw through year 11. So my first computer science GCSE cohort many years ago, after the exam, I was so upset that I didn't teach this more, because whilst it didn't directly examine modulo on that paper, they had a task, a programming task, and kids had to write the pseudocode for that. So it wasn't coding, but they had to write the pseudocode. And the way if you knew about modulo, if you knew about that little trick, and it had to do with going through the elements in a list, if you didn't know about modulo, it would be so much harder. So I would say it's deeply important. It's super important. Not so much that you need it, but it makes your life so much easier. It's one of those. It's
a very useful concept. Brilliant. Yeah. Thank you very much for your questions, everybody.
Yes, and thank you, Melanie. It's been a pleasure having you with us for the last couple of sessions. I know I've learned a lot, and I'm sure everybody else has, so thank you.
Thank you. Thank you. Thank you.
That was fantastic. If you want to test your knowledge on everything you've learned today, you'll find a link to this week's game board in the chat below. And there are also loads of hints to help you find the right answer if you're struggling with all the questions. And there's that game board.
Yes, and if you want to watch any of our live stream sessions back for revision, to expand your knowledge, or even just to see Slytherin the Snake again, you can find all of them in our live stream gallery.
Our next session will be in 2 weeks' time on Wednesday, the 30th of November, with our very own Pete Bell.
Yes, Pete is a learning manager at the Raspberry Pi Foundation, and he will be taking us through variables and constants, another fundamental programming concept. You can book your place on the website or by using the link that hopefully is going to pop up below.
Excellent. And let us know how you found today's session by filling out the feedback form below. You can also let us know if you have any suggestions or topics you would like us to cover. We've got all the links this afternoon, Laura.
Yes, thank you so much for joining us, everyone, and hopefully we'll see you next time.
Bye.